Hi, in this lecture series, we'll be discussing about chemical reaction engineering. Chemical reaction engineering deals with reactions and the design of reactors for those reactions. To design a reactor, we need to know the kinetics of the reaction. Now, the kinetics of the reaction depends on the type of reaction. Let us discuss the type of reaction based on the phases. Based on phase, reactions can be of two types, homogeneous and heterogeneous. Homogeneous reaction involves only one phase, while heterogeneous reactions proceeds with more than one phase. The phase may be 2, 3, but it is not one, it is more than one. Apart from the phase of the reaction, there are other factors that affect the rate of the reaction. So, let us say a reaction is homogeneous in nature. Then factors like temperature, pressure and concentration affects the rate of the reaction. Now, when we say a reaction is heterogeneous, in heterogeneous we know that it involves more than one phase. So, since there is more than one phase, there will be mass transfer taking place between the two phases. Hence, the mass transfer coefficient also comes into picture along with temperature, pressure and concentration. To understand this better, let us consider a reaction taking place inside a pellet. Let us say the reaction is exothermic, meaning it will release heat. So if this reaction is taking place inside a catalyst pellet and if we do not remove the heat continuously from the catalyst, then the temperature will begin to rise. So if the temperature begins to rise, there will be different temperature at different points inside the catalyst pellet, due to which the rate of reaction will be different at different points inside the catalyst pellet. From this, we can understand that heat and mass transfer coefficient affects the rate of the reaction. Thus, heat and mass transfer coefficient plays an important role in the rate of reaction for heterogeneous reactions. The rate of a reaction. But what exactly is the rate of a reaction? How is it written? How is it represented? Before we know how we write the rate of a reaction, we need to one component from a reaction based on which we'll write the rate of reaction. Generally, the rate of reaction is based on the limiting reagent. We will understand this concept of limiting reagent later. For now, let us choose I as a component based on which we'll write the rate of reaction. Rate of reaction is nothing but rate of change of component I in the reaction. We can write rate of reaction in different ways. We'll now learn how to write rate of reaction. Based on unit volume of reacting fluid, we can write rate of reaction as rate of reaction of component I is 1 by V d Ni by dt. This is nothing but moles of I formed or reacted upon volume of fluid in the reactor into time. Secondly, we can define rate of reaction of component I as based on unit mass of solid in fluid solid systems. Based on unit mass of solid, we can write rate of reaction of I as 1 by W d Ni by dt. This is nothing but moles of I formed or reacted upon mass of solid into time. W here is the mass of solid. Generally, it is the mass of the catalyst. Next, we can define rate of reaction of I as on the basis of surface area of solid in gas-solid systems. So we can write rate of reaction of I is 1 by S dNi by dt. Again, it is nothing but moles of I formed or reacted upon surface area of the solid catalyst into time. Next, we can define rate of reaction of I based on volume of solid in gas solid systems, which is again nothing but 1 by Vs into dNi by dt. Here Vs is the volume of the solid. Next, we can define rate of reaction based on the volume of the reactor, which is 1 by Vr into dNi by dt, where Vr is the volume of the reactor. For homogeneous systems, the volume of the fluid is equal to the volume of the reactor, and hence the first equation that we discuss will be same as this equation for homogeneous systems. With this, we come to the end of our first discussion.